Hello everyone, we continue the discussion on the laws of logarithms by trying to answer this question. Write the expression as one logarithm. 2 times the log of y to the 10 over x minus 4 log y plus 1/2 log x to the 4th y squared. Recall the laws of logarithms. The product law, which says log of x times y is equal to log of x plus log y. The quotient law, which says log of x over y equals log x minus log y. And the power law, which says log of x to the k is equal to k times log of x. We apply the power law to 2 log of y over 10 over x minus 4 log y plus 1/2 log s to the 4th y squared. First, applying law 3, we can move this 2 over, this 4 over, and this 1/2 over. So we have log of y to the 10 over x all squared, subtract log of y raised to the 4th plus log of x to the 4th y squared raised to the 1/2. Continuing expanding this, we have this being equal to log of y to the 10 times 2, which is 20, over x squared minus log of y to the 4th plus log of x to the 4 times 1/2, which is 2, and the y 2 times 1/2, which is just y to the 1, which is y. Now, applying the law 2, which is the product, which is the quotient law, we have log of y to the 20th over x squared. We're subtracting logs, which means that we are dividing exponents. So this y to the 4th comes to the bottom. And then this will be plus log x squared y. Let's continue simplifying this. Y to the 20 or y to the 4th will give you y to the 17th, or 20 minus 4, which is 16, over x squared, right, plus log of x squared y. And then applying the product property to this, bringing the logs together, this would be log of all of y 16th x squared y over x squared. And then this simplifies to give you log of y to the 17th. And that's your final answer. Okay, there goes your final answer. All right, let's continue working with the laws of logs to solve this expression. Express f of x is equal to 2 to the negative 2 log 2 3x plus 9 without logarithms, right? First of all, we want to apply a law 3. So if we apply power law, we can rewrite this as 2 log base 2 3x plus 9 to the negative 2. Because applying the power law, we can move this negative 2 up to an exponent position. Then knowing a property of log that says if you have an exponential function raised to the log of the same base, they are inverses of each other, then they will undo each other. So this 2 raised to the log 2 will undo each other. So what we are left with is 3x plus 9 to the negative 2. And this is a negative exponent, so using the rule that we know about exponents, as negative is 1 over the positive exponent. So this becomes 1 over 3x plus 9 all squared, and then that is your final answer. Right? So f of x is equal to 1 over 3x plus 9 all squared. Let's talk a little bit about the domain and range of log functions. Remember that in our original log function, your domain was 0 to infinity, 0 to positive infinity, and your range was negative infinity to positive infinity, right? And this original log function passed through 1, 0, and also if you're doing log base a to the x, then this other point would be a comma 1, right? So if you were log base 10, that would be 10, 1. Log base e, that would be e1, e comma 1, and so on. Okay. What we know about log functions is that the argument must be greater than 0. Thus, the domain consists of values for which the argument is strictly greater than 0. So if we consider the function f of x is equal to log of x squared, its domain consists of all values for which x squared is greater than 0. So if we had x squared greater than 0, right? X squared is greater than 0. And so these are all the numbers which would be positive or negative. You square them, it does not include 0. So its domain would be negative 1 to, no, negative infinity to 0, union 0 to positive infinity. Now, if we look at the function f of x is equal to 2 log x, which you can look at it like you're taking the square to in front of the log. And based on what we were doing previously, you would say that these are equivalent expressions. However, the domain of 2 log x is not the same as the domain of log of x squared, because this x is what has to be greater than 0. So then the domain of this function is x greater than 0. So the interval notation is 0 to positive infinity. So then log of x squared equals 2 log x. For this statement to be correct, we have to qualify it by saying that x occurs where x greater than 0. So in these two cases, one of them, the domain is negative infinity to 0, union 0 to infinity. In the other case, for x greater than 0, your domain would be 0 to infinity. So they're both equal where the domains are equal, which is where x is greater than 0, right? Let's look at an example working with finding domains of functions. Now suppose we ask the graph f of x is equal to negative log of 2x. Remember we said that on our graphs with basic log functions, they will always pass through the points 1, 0, and then whatever the base is, and 1. So if you're taking the log of negative of log 2x, we would have the points passing through 1, and using 2, plugging that into your f of x, we have 1, 0, and 2, negative 1, right? So the graph would pass through these points, And so let's check your domain for this. Your domain here, domain for this function would be 0 to positive infinity, right? And then the range would be negative infinity to positive infinity. Okay? The domain is 0 to positive infinity, and then the range is negative infinity to positive infinity. Now, let's look at another example. Find the domain and range of f of x is equal to log of 1 minus 3x. F of x is equal to log 1 minus 3x. Okay. Log without a base written is log base 10. Okay? So we want to find the domain of this. We want to set the argument equal to 0. So domain, we set the argument equal to 0, greater than 0 on arguments. Set argument greater than 0. So 1 minus 3x is greater than 0. We try to solve for x. So if we add 3x to both sides, we have 1 is greater than 3x. And then if we divide both sides by 3, to undo the 3 on the side with the x, we have 1/3 is greater than x. So in this case, x would be less than 1/3. So your domain would be from negative infinity to 1/3. And that's your domain. So you're asked to find the domain. The range, there's nothing here that would affect our range. So the range would be the same as our original log function, which is negative infinity to positive infinity. And we're done. Let's apply domain and range ideas to another problem. Our problem asks us to find the domain and range of f of x is equal to 5 minus e to the 6x. F of x is equal to 5 minus e to the 6x. And you're taking the square root of that. The square root of 5 minus e to the 6x. What we know about the radical restriction is that anything underneath the radical, which in this case is 5 minus 6x, must be greater than 0. So 5 greater than or equal to 0. So 5 minus e to the 6x is greater than or equal to 0. So let's do some algebra here. If we add 6x to e to the 6x to both sides, we will have 5 greater than or equal to e to the 6x. Then we want to solve for x. If we're solving for x, we want to take ln both sides. Take ln both sides, or take ln of both sides. So I have ln of 5 greater than or equal to ln of e to the 6x. The inverse functions here, ln and e, would undo each other. So ln of 5 is greater than or equal to 6x. And then divide both sides by 6. Get an answer. So ln of 5 over 6 greater than or equal to x. So to write this domain in interval notation, then, interval notation or domain is negative infinity to ln 5 all over 6. All right, included, so we put a bracket, and then that is our final answer. Don't forget to like and subscribe for more videos. Thank you very much for watching.